Hello and welcome to World Mycotoxin Report, Impact 2020, Americas and EMEA edition. This is a webinar brought to you by BIOMIN and Romer Labs. We're broadcasting from the EVA Group World Headquarters in Austria. My name is Josh Davis and I am the Communications Manager at Romer Labs and editor of our bi-monthly magazine, Spot On. It's good to be here with you. I'd like to welcome today's three panelists to our webinar. Those of you who joined us last year will recognize Alexandro Marchioro, senior mycotoxin expert at BIOMIN. Hello, Alex. How are you doing?
Fine, good.
You spent a lot of time on the road talking about BIOMIN and educating people about mycotoxins. Have you been anywhere interesting this year?
Yeah, it was a busy year, traveling around the world promoting the BIOMIN survey and services. So I have been in Americas, Europe, China, for example. And based on the data that we will present today, I think this year also will be a busy year, right, for us.
Well, good. Busy is good for us. We like to be busy.
Yeah.
Right. We're also happy to welcome back to the webinar Martina Bellasio, the senior mycotoxin expert at Romer Labs and the star of our Mycotoxin Minute videos, which you can find on LinkedIn and our other social media channels. Martina, tell me, is there anything exciting and new that we can expect from the Mycotoxin Minute this year?
Well, hello and welcome also from my side. Yes, we are actually preparing a lot of new videos. These will give you a more scientific insight into the world of mycotoxins.
Okay, you mean so more than just numbers?
Exactly.
All right. Looking forward to that. Of course, I also do the odd Mycotoxin Minute video, and something I also enjoy and look forward to as well. And joining us for the first time is Anneliese Mueller, Product Manager for Mycotoxins at BIOMIN. Anneliese, welcome.
Thank you.
Is this the first time that you've worked with the BIOMIN survey?
So I've been here now for quite a while, and already last year I could work on it.
All right, so you're already very familiar with the survey and how it works. Why don't you tell us something interesting about that you've learned about the results this year? Is there anything that stands out to you?
So there are lots of interesting things, and I don't want to spoil it, but for me, as I'm now focusing a bit on emerging mycotoxins, those results are the highlight for me.
All right, so emerging mycotoxins, co-occurrence, things like this. This is very much in focus in this year's webinar, isn't it?
Exactly.
Good. All right. Well, I know that everyone here is eager to hear the results from the BIOMIN World Mycotoxin Report, but first, a few words to our audience. This is the Americas and EMEA edition of the webinar. While we will be touching on mycotoxin occurrence from every region, we're paying special attention to what's going on in North and South America, Europe, Africa, and the Middle East. I'd also like to remind you that this is an interactive webinar. When you open the toolbar on the right-hand side of your screen, you'll find a chat function for issues regarding audio, visual, or other technical settings within the webinar platform. The questions function can be used at any time throughout the session, so please feel free to enter questions for our speakers and for the Q&A session later on. If we can't get to your question over the course of the webinar, we may contact you by email afterwards with an answer. So please don't be shy. We want to hear from you. So let's get started. And I'll start just with a very general question for Alex and Anneliese. Why do you do this survey? Why does BIOMIN do this survey?
Good, I can answer this. So this service is part of the technical service that we offer for our customers, right? So we collect all the data to help them to be informed about which mycotoxins are found, where, and at which concentration. And we ask also, what is the risk they are coping with? So based on all this data, we can give our hints, right? So this survey is also important for us as a company to help us in our research and to develop new products and tools for the customers. And as you can see, we have been able to increase the number of samples we analyze every year. So these samples are mostly routine analysis for mycotoxins in feed and raw commodities. Such tests help us monitor the mycotoxin risk for animals. And in 2019, we had for the first time over than 20,000 samples.
That's quite a lot. And you brought us a preview of this year's BIOMIN Mycotoxin Survey results, haven't you? Let's take a look at the numbers. Well, BIOMIN has run this survey every year since 2004. And this year you tested 21,287 samples of finished feed and raw materials sourced from 86 different countries. What does the picture look like globally?
Good. So let's have a first look on the world map contamination. So first of all, I would like to explain how to read this map. So for all subregions, we listed the prevalence for the main mycotoxins analyzed in the boxes. So you can see how many samples tested positive for aflatoxin, zearalenone, deoxynivalenol, T2 toxin, fumonisin, and ochratoxin A. So in this world map, the subregions of the world are colored according to the percentage of samples above the risk threshold.
What exactly do you mean by risk threshold?
Well, the risk threshold are defined by BIOMIN and are based on worldwide practical experience in the field and also with scientific trials and according to the literature. So yellow means moderate risk, up to red representing extreme risk with more than 75% of the tested samples above the risk threshold. So we can see that all regions are affected by mycotoxin. And the occurrence and concentration that we observe pose a potential threat to swine, poultry, ruminants, and aquaculture production. As we try to improve our services to customers all the time, I'm happy that this year, for the first time, we included the risk for aquaculture industry in our survey.
I see. You're billing today's session as the impact of mycotoxins this year, so in 2020. According to your analysis, what are the trends regarding the most prevalent mycotoxins?
Well, to talk about trends, we can show this slide with the 10-year trends in corn. So the bars represent the prevalence and the lines represent the average of contamination in ppb over the last 10 years. So we can see that the co-occurrence of these two mycotoxins, fumonisins and deoxynivalenol, it's high, and based on the field experience, these averages of contamination can cause expressive losses on animal production. Additionally, this can affect especially the most sensitive phase like reproduction and starters.
So could this trend be observed for all regions worldwide?
Yes, we have observed these trends on nearly every continent.
So you have many different mycotoxins in the mix here. Do these occur in similar patterns everywhere, or is there geographic variation?
Well, let's go through the data region by region to explain this part. And we have a separate map for each region that shows the subregional risks. Let's start with North America. Risk in North America is extreme. So we can always still remember that the heavy floods last year in the US, it was called the worst flooding disaster even to hit the region, referring to areas along the Mississippi, Missouri, and Illinois River. And this really impact the 2019 corn, soybean crops. But let me explain how to read the graph. So the gray bars indicate the prevalence of the main mycotoxin detected on all analysis performed. So we also can compare with the prevalence of that same mycotoxin presented in the previous year. The picture of animals are colored according to the proportion of samples above the risk threshold for each animal species. So each animal's colors indicates the risk posed to the species by the prevalence and concentration for each mycotoxin in all samples from this region. So clearly, DON is one of the main concern in all species. And DON was present in 90% of finished feed samples analyzed, with a maximum concentration of 8,936 ppb. And we observed a high deoxynivalenol prevalence where 85% of samples were contaminated with this mycotoxin, followed by FUM with 78%. And going through more data about this region, let's guide you through this slide. In this figure, to the right, we see the co-contamination. So how many mycotoxins are present in a sample? One or more than one. In this material, we detected a high co-contamination where 75% of samples were contaminated with more than one mycotoxin. Here in the left corner, you can see the prevalence of the main mycotoxins. And on the top, in the table, we can see the numbers of samples investigated, average and maximum values. So the average of contamination were quite high for DOM with 1,011 ppb, fumonisin with 2,839, and zearalenone with 285. So another important corn byproduct, dried distiller grains with solubles, the popular DDGS, was especially subject to DOM contamination. So the prevalence was at 99%, and there was an average contamination of 6,473 ppb. So the corn trends for this region show us that the fusarial mycotoxins are increasing their prevalence over at the last 5 years.
So Alex, there's a lot of numbers here in play. Can you give our listeners a 2-sentence summary about what they should keep in mind?
Yes, of course. Definitely DON and FUM were the highest threats for this region. And we know that these two toxins can work together to make things even worse for the animals.
All right. So what about the countries in Latin America?
Okay, let's change the region. So let's move to Central and South America. In these regions, risk is high. So Central America, it's at the extreme, and South America at several risk. DON is present in 69% of cereals samples, and they tend to test high average concentration with more than 1,500 ppbs. Fumonisin is the most abundant mycotoxin in these regions. It contaminates 90% of corn, 100% of the DGS, and 85% of finished feed samples. In a concentration as high as 107,000 ppb of fumonisins was found in a corn sample. But let me show more details for some countries in these regions. Let's start with Mexico. So for corn, the most common mycotoxin was fumonisins at 96% prevalence, followed by deoxynivalenol at 53%. Additionally, fumonisins presented a high average of contamination with 5,527 ppbs. Let's go through to the south, starting with Brazil, one of the most important countries in the region producing and exporting raw material for animal production. So we detected a high prevalence of FUM, where 91% of corn samples were contaminated with this mycotoxin, followed by the deoxynivalenol with 57%. FUM presented an average of 3,155 ppbs with a maximum concentration also over 107,000 ppbs. Going to Argentina, the situation was quite similar and the contamination was particularly high. In corn, FUM was high at 3,795 ppb on average, followed by deoxynivalenol with 720 ppbs.
Wow, so it looks like all the Americas are exposed to high levels of mycotoxin contamination. This especially seems to be true of fusarium toxins, right?
Yes. North and South America are showing high risk for all animal species, especially regarding FUM and DOM, as we presented.
All right. Well, thank you for those insights and that summary. So for Europe, we've invited Anneliese to present the main results. So Anneliese, tell us, which mycotoxin contamination do we see in Europe?
I can tell you that we see for overall risk in Europe a high to severe one. The most prevalent mycotoxin is still deoxynivalenol, followed by fumonisins, which decreased slightly compared to last year. Also, cerealenone still shows high abundance. The risk in Europe is mainly due to concentrations of deoxynivalenol. Especially during this harvest, we observed high abundance and concentrations of this mycotoxin in cereals and corn. Let's have a look at deoxynivalenol in corn and cereal samples from all over Europe. We see that 83% of samples tested positive for this toxin, followed by 73% with fumonisins. In cereals, we could detect deoxynivalenol concentration as high as almost 22,000 ppb.
So can we observe this in all subregions of Europe?
No, mycotoxin contamination is varying, especially due to different weather conditions and climate, and also the grains that are produced. And while in Central and Eastern Europe, deoxynivalenol is the most prevalent mycotoxin, in Southern Europe it's fumonisins with 85% and an average of over 700 ppb. Interestingly, in Northern Europe, T2 is even more abundant than DON, but at low concentrations.
I see. So we've got a great deal of information about the Americas and about Europe right now. Do you have any insights for Asia?
Yes, of course. In general, Asia has again seen the same high risk level as last year.
So extreme risk, in other words.
Yes, mainly extreme risk, apart from moderate risk in Australia and New Zealand. In Asia, we see increased level of fumonisins and cerealenone. The deoxynivalenol remains at high occurrence. This is a severe risk for swine, poultry, and aquaculture industry. And also aflatoxin, it's still a problem. Having a first glance at commodities, we see 31% of corn samples tested positive for aflatoxin with a maximum of over 700 ppb. In finished feed, even 99% of all the samples were contaminated with fumonisins, with a maximum of 41,471 ppb.
That's pretty high, isn't it?
Yeah, I think so too.
Do we also get a lot of samples from Africa and the Middle East?
Yes, we have quite some samples from this region. Let me show you some results for Middle East. Here are some highlights for this region. Fusarium toxins are most prevalent. 97% of finished feed samples tested positive for fumonisins, and a maximum of over 4,300 ppb was found. Average concentrations are rather moderate, but the maximum of deoxynivalenol was elevated with over 1,700 ppb in all of the samples. Let's move on to Africa. Considering sub-Saharan Africa only, the risk even increased to extreme compared to last year. This difference is mainly based on contamination with aflatoxins, which show high prevalence in corn and finished feed. Main risk in whole Africa is due to deoxynivalenol, followed by FUM. And as you asked about samples, Josh, particularly from South Africa, we receive lots of samples.
Well, thank you, Anneliese, for these insights. The high prevalence of mycotoxin occurrence we've seen here makes it even more important for feed and grain producers to test for mycotoxins. And this is where our experts at Romer Labs can tell us a thing or two. So Martina, Alex and Anneliese have pointed out that co-contamination is a real problem. In other words, commodities are often contaminated by more than one mycotoxin.
Yep, yeah, exactly. And of course, this is true for all sorts of other metabolites that fungi produce, and not just for the handful of regulated mycotoxins.
So AFLA, DON, and the usual suspects,
Yeah,
right?
exactly.
Yeah. There we can see a slide of these usual suspects. So I understand that you have a concrete example of co-contamination that you'd like to share with us. Does this involve both regulated and unregulated mycotoxins?
Yeah, exactly. In this case, it involves aflatoxin and diacetoxyskilpinol.
Well, say that fast 3 times. Does it have an easier to say nickname like afla for aflatoxin?
DAS. Let's just call it DAS.
DAS. Okay, got it.
And in the example we'd like to share with you, a Romer Lab customer had a problem with swine, barrows to be precise, that were performing poorly. So they were showing very low body weight gain, and the analysis of their feed showed traces of aflatoxins, but not enough to justify the symptoms. So in this particular case, it was necessary to get a more comprehensive picture of the toxicological pattern of the feed given to the barrows. And only with this data, it was possible to make a differential diagnosis. This feed was actually contaminated not only with aflatoxins, but also with DAS. This is a mycotoxin from the group A trichoticins produced by fungi of the genus Fusarium.
And as we always like to say in the Mycotoxin Minute, just because it isn't regulated
doesn't mean it's not dangerous.
That's right. So whenever we're confronted with more than one mycotoxin in a sample, we always need to ask ourselves what kind of effect they might have on each other, right?
Exactly. And we often talk about the differences between additive and synergistic effects. Relevant to this case is that aflatoxin and DAS can have additive effects, which means that the toxic effects of these two mycotoxins merely equals the sum of their individual effects. Toxicological interactions of mycotoxins can also be synergistic, and this means that the effect of 2 or more mycotoxins present in the same sample will be higher than the sum of the effect of the individual mycotoxins.
In other words, the synergistic effects are worse than the additive effects.
Exactly.
Generally. Okay.
Very good. And actually, in recent years, the scientific community has focused on unregulated fungal metabolites, and more evidence on their toxic effects has been collected. And the term emerging mycotoxin is currently used to underline how these analytes have been gaining awareness in the analytic community.
And I'm going to try to say it now, diacetoxyskilpinol is one of these emerging mycotoxins, I assume.
Exactly. Yeah, very good. It's one of the many that have been linked to any number of toxic effects. Others are listed here and are, for example, petulin and buvericin, which both negatively affect the immune system. Yet another is fusaric acid, which has negative effects on the nervous system of swine. Ergot alkaloids are a special class of compounds causing fat necrosis and reproductive dysfunction, while moniliformin is particularly toxic to the heart. Other toxic metabolites that have gained more and more attention in the last years are the so-called masked mycotoxins. So when fungi infect a plant, they release a wide range of metabolites, including the well-known deoxynivalenol and zearalenol, just as part of the infection process. And often, the host plant will modify these compounds coming from the fungus. The chemical modification is the so-called mask that hides the true identity of the mycotoxin, making it often overlooked in traditional mycotoxin tests. And usually a glucose molecule or a sulfide group is attached to the fungal metabolites.
I'm sorry if I can just interrupt here.
Yeah?
Why would a plant modify a compound like that? What's in it for the plant?
Well, according to the best theories we have, plants do this as a detoxification strategy. But actually, this detoxification only protects them.
And not the animals that
exactly
eat this. Okay.
Because let's take, for example, the deoxynivalenol 3-glucoside. When it enters the gastrointestinal tract of an animal, the bacteria that live there cleave the glucose group from the rest of the compound. And the unmasked compound is once again toxic. An interesting side note on this topic, novel plant breeds that are selected to be resistant to mycotoxin-producing fungi often accumulate a higher percentage of masked mycotoxins compared to the non-resistant variety. So this is really a hot topic right now.
Okay, so let's sum up a little bit. I count one, maybe two concepts here at play. One, there is increasing evidence that many fungal metabolites have toxic effects on animals. And two, the simultaneous presence of several mycotoxins can exponentially increase the toxicity of a sample, right?
Yes, exactly.
So this is my question for you. How can we get information on the whole contamination level of a sample if traditional rapid tests are available only for regulated mycotoxins?
And our reply here is liquid chromatography tandem mass spectrometry, or LC-MS/MS for short, that is currently trending as the method of choice for detecting multiple mycotoxins in one sample. And the advantages of LC-MS/MS include not only the ability to perform multi-mycotoxin analysis, but also its high selectivity and sensitivity, meaning that we can get results in the par per trillion range for most mycotoxins. This is what an output of an LC-MS/MS analysis looks like. The sensitivity and selectivity of the instruments allow us to identify and precisely quantify many different metabolites in just one run. And it just so happens that Romer Labs offers the most comprehensive LC-MS/MS multi-mycotoxin analysis commercially available, and it's called the Multi-Mycotoxin Analysis 50 Plus. And this gives us a unique insight into the contamination pattern of a sample with more than 50 mycotoxins quantified. The method is validated on wheat, corn, swine feed, and silage. And here are the several criteria that we applied for selecting toxins included in the multi-mycotoxin analysis 50 plus method. So of course, all the regulated mycotoxins are included together with emerging and mass mycotoxins for which toxicity data is available. And last but not least, only toxins with high quality analytical standards available on the market were selected.
Well, thank you, Martina. And I just want to stay with this topic of mycotoxin analysis right now. If I'm not mistaken, Anneliese, I'd like to bring you in back into the conversation. Multi-mycotoxin analysis 50 plus from Romer Labs is a vital component of the Spectrum Top 50 service that you offer at BIOMIN. Is that right?
Yes, that's correct. And in the meanwhile, we already have a lot of data on the occurrence of emerging mycotoxins, and I'm already excited to present it to you. What looks so complicated at the first sight is a list of the emerging, the masked, and the well-known mycotoxins. They are listed according to their abundance, so on top is the most abundant one. In this year, fumonisin B2, which was most abundant in the almost 3,000 samples we analyzed. To the right, we list the average of each mycotoxin and the maximum values. In orange, you see the well-known mycotoxins, in red, the masked ones, and in blue, the emerging ones. Results are shown here for the 25 most abundant toxins. Most frequently found emerging mycotoxins are here ovaricin, eniatines, and moniliformin. Martina, you have already mentioned ovaricin. It has been linked to negative effects on immune system. Eniatines show similar effects, and moniliformin has already been mentioned for its known toxic effects, particularly on the heart. For this emerging mycotoxin, also additive effects have been observed with fumonisins in poultry and with dominant fumonisins in swine.
Do we see any masked mycotoxins here?
Yes, in 35% of the samples tested, we see DON3 glucoside, and you can see it highlighted in red. So here you can see the world map we already presented to you many times today. The risk is based on the 6 investigated well-known mycotoxins. I've now added the 3 most often found emerging mycotoxins for each region in the blue samples. Interestingly, although regions and commodities differ, for example, soybean I present in South America, and wheat in Europe, we see that some emerging mycotoxins are really frequently found. Ovaricin, eniatines, moniliformin, also alternario. Ovaricin was most prevalent in samples from North America and in soybean from South America. Moniliformin was most abundant in corn from Africa and in finished feed from Asia. But there is still much to find out about these mycotoxins. Some are present at very low concentrations, as indicated in the circles. So we have to question ourselves, is this actually of concern, or are there any synergistic effects?
So if I understand you correctly, this means that we still need a lot of research to answer these questions, right?
Definitely.
Well, so this leads me just to one other question, if I may. We know that there are over 400 fungal metabolites out there that could be toxic. How do we test for those that don't meet the criteria for the 50 methods that are offered by Romer Labs and BIOMIN?
That's a very good question. In our experience, there are always a few cases where customers can't get the root of their mycotoxin problem with our Spectrum Top 50. To get those details, we use a method with the capacity to detect more than 400 metabolites. We call it Spectrum 380. During the last year, 790 samples were analyzed with this method. We can see that the co-contamination where multiple mycotoxins are present is very common. Have a look at the graph on the left. On the x-axis, we have the metabolites per sample, and on the y-axis, we can see the proportion of samples in percent. And most of the samples contain between 20 and 29 metabolites. On average, we see 35 metabolites per sample, and we also observed that 9.7 out of 10 samples were contaminated with fusarium toxins. We can also see that 90% of all the samples were contaminated with more than 10 different toxins and metabolites.
Well, many thanks to you, Anneliese, and to you, Martina, for these insights into multi-mycotoxin analysis. Now I'd just like to sort of steer the discussion to another issue, but much related to this one. Once you have the test results in hand and you've identified that you have a contamination issue, you're probably going to want to mitigate the risk to your animals. So tell me, Alex, what is it that BIOMIN can provide to the market?
Well, you know, we always need to find a way to protect our animals in our production. Yeah, and as you know, and also Martina and Anneliese already showed to us that mycotoxins have different structures. Yeah, and that's why we need different strategies also to counteract them. So BIOMIN has the MYCOFIX product line that works with 3 different strategies. So first of all, it's absorption via bentonite. It's a proven solution, and it's gone through the full process to the EU authorization for binding aflatoxins. And then we have the biotransformation components containing FUMzyme for the degradation of fumonisins, BBSH for the breakdown of trichothecenes, and the MTV component, counteracting zearalenone and ochratoxins. And on top of this, MYCOFIX contains the bioprotection components to support and protect the liver and immune system of the animals against the effect of mycotoxins. And as we know, BIOMIN is always innovating and developing new solutions to counteract the mycotoxin, and using science and high technology, we presented to the market a new product, the FUMzyme Sol. So the only enzyme against fumonisins now available as a liquid application. So for more information about our products, please contact a BIOMIN representative. Sorry.
Great. Well, thank you for these insights, Marchioro. I'd like to point out that that BIOMIN has a new website which contains lots of technical articles, survey data, as well as product information. And aside from that, it also looks really good, in my professional opinion.
Yeah, definitely.
Very nice.
So congratulations to all of you at BIOMIN who worked on that. So this brings us to our question and answer right now, our Q&A session. I'd like to thank everyone who took the time to ask a question, be it during registration or over the course of this webinar. As I said before, we're not able to get to all questions, so we've tried to pick a few that are representative of the types of questions that we tend to get. And this first one is going to go over to you, Martina, because it's dealing with diagnostics and analysis. In your opinion, and I think we get this question a lot, don't we? What is the best simple methodology for mycotoxin screening? And I guess by simple, the questioner means that it doesn't include high performance liquid chromatography. So any of the lab methods, right? So
Yeah.
HPLC, gas chromatography, or tandem MS.
Yeah, you're right. This is a question we get a lot, but there are many options for a quick and simpler detection of mycotoxins in samples. There are, for example, strips that can be used also on site to get the first estimation of the mycotoxin content.
And by strips, you mean LFDs, right? So lateral flow devices.
Yes,
okay.
Yes. There are also ELISA that require a few lab instruments, but they are actually quite easy to perform and can also analyze a lot of samples in parallel. So we are pretty spoiled with options in this case.
That's a good problem to have then. I think this next one is a question for BIOMIN. I'll just read this out. This is to do with an important sector in our industry, poultry. How vulnerable are commercial poultry to mycotoxins? Is there any correlation between the level of mycotoxin contamination in poultry feed with prevalence of clinical signs in flocks?
Good question. Yeah, definitely the birds are exposed for and sensitive for this different mycotoxin, and especially broilers. In this question, we know that the first 3 weeks or the starters phase are the most important phase, and definitely, as we saw in our mycotoxin survey, we have normally a cocktail of these different mycotoxins. Mm-hmm. So definitely these contribute and affect the animals directly, and especially can also contribute for different disease, because mycotoxin can open the door for bacteria, virus, and we talk about E. coli, Salmonella, etc. So mm-hmm. This also
because the mycotoxins weaken the animals, right?
Exactly.
They make them more susceptible to disease.
Exactly. Yeah. So mm-hmm. Definitely broilers are exposed for these risks. Yeah.
I see. I think this next question is also for BIOMIN. Is it possible to fix all the mycotoxins in a feed formulation? Is there any method to reduce mycotoxin levels without using binders? All the mycotoxins, anytime I see the word all, I think the answer is almost always no. But you're the experts. What do you say?
Yeah, for sure. Not for all. Huh? But definitely we already know that MYCOFIX, for example, can counteract more than 200 mycotoxins, but definitely not all. We are investigating, and with the research, we always discover new metabolites, new mycotoxins, and we are doing studies to identify the toxic effects and the interaction that they also have with the normal mycotoxin, or the mycotoxin that we presented today, for example. But of course, the customers can use some products, for example, to control mold in the storage place, to try to reduce the mycotoxin production. But unfortunately, we cannot do anything against the mycotoxin that were produced in the field. So against these mycotoxin, we need to use additive, definitely.
I see. Well, thank you. The questions are still coming in. Thank you again to all of you who are asking them. This seems to be sticking with the topic of feed, and this is a question that I'm going to throw over to Martina. What is the most effective and accurate way to test for mycotoxins in animal feeds? I'm sorry, I read this incorrectly. The most efficient and accurate way to test for mycotoxins in feed. Mm-hmm. This is a pretty broad question, isn't it?
Yeah, it is a broad question. It is also a question that we get also very often. I would summarize my answer with one important concept that I think always needs to be taken into consideration when comparing different methods. And the fact is that there is no absolute best method. There are only methods that are fit for purpose or not. So the testing method that is best in one case is the one that fits one necessities. So for a fast screening at a grain collection point, just like we said before, the best method will be strip or analyzer. But for a multi-mycotoxin analysis that needs to include regulated and emerging mycotoxin, the method will be an LC-MS analysis.
Right. This is the only one that can give you feedback on co-occurrence.
Exactly.
Right. Makes sense. There's another question coming up for BIOMIN. How will the reduction in pesticide use and the change in climate affect mycotoxin occurrence in different regions of the world? What is the forecast for mycotoxin contamination in the next 5 years? So Anneliese, can you look into your crystal ball and tell us what's going to happen with mycotoxin contamination over the next 5 years?
So I don't see a clear picture yet, but I have a few things in my mind that I want to let you know. So first, Marchioro, Alex mentioned the toxins that are produced in the field. And what you can do before when fungi are growing, it's to use pesticides. So when there are less fungi, there will be also less toxins. So this has for sure an impact. And then we see due to climate change that there are extreme weather conditions happening. We have mentioned the floods today. And after such events, we always see an increased toxin risk in the regions. And one other thing we can already recognize is that toxins that are usually found in southern regions, like the fumonigens and aflatoxin, they are moving to the north. So this is also due to climate change.
Okay, so as the climate warms up, then fungi that are able to grow or thrive more in the warmer regions, like Fusarium, are also moving with the shifting climate. Is that correct?
We observed this.
Yeah. All right. So I think we're coming down to oh, I'm sorry, Marchioro, you wanted to say something. Go ahead.
No. It's just a comment regarding this topic. We are always trying to develop new services, as I said before, to our customers, and thinking in this way, we are trying to develop a tool to predict this mycotoxin contamination, considering all these critical points, fungicide or climate changes, and also temperature in the field. So how these try to quantify how these impact and can contribute for the mycotoxin occurrence. So I think in the next years we will also develop it and publish a tool to quantify or try to quantify these topics also.
All right, so a mycotoxin prediction tool is what we're talking about.
Exactly.
That sounds exciting.
Yeah.
Good. We've got one more question. This one is also for you, Martina. We get a lot of questions about sample preparation at Romer Labs. So just let me ask you, how do you prepare a sample for mycotoxin testing?
Well, yes, this is very, very important. Actually, probably the most crucial step of the whole analysis. And it is of fundamental importance that the sample is representative. Because, mycotoxin distribution in grains is typically uneven.
Now, there's the so-called rule of hotspots, right?
Exactly, they grow in hotspots, the fungi. So, as a general indication, usually we collect incremental samples as described by the sampling guidelines that are in place in the respective countries. But actually, a detailed step-by-step preparation of the samples for mycotoxin analysis is described in our sampling guide that will be provided to the participants.
All right, thank you. Thank you to our panelists, and thank you to everyone who asked a question. This brings us to the end of our Q&A session, and it's also approaching the end of our webinar. Now, as we promised, you'll be getting a few goodies from us. You'll receive an email including links to today's recording. You'll be getting the brand new BIOMIN Mycotoxin Survey annual report, a Romer Labs mycotoxin sampling guide, and a link to a short on-site mycotoxin testing video. You'll get all this within the next 24 hours. And this is also very important. You'll be prompted to answer a short survey on today's webinar after the webinar concludes. It should take no more than 2 minutes to complete. By providing your feedback, you allow us to improve our webinar program and identify future topics for discussion. We would very much appreciate your taking the time to complete the survey. So it just remains for me to thank our panelists, Alexandro Marchioro.
Thank you very much.
Anneliese Mueller.
Thank you.
And Martina Bellasio.
Thank you, it was a pleasure.
This is Joshua Davis from Romer Labs saying visit us at biomin.net or romerlabs.com to learn more about how we can help you develop a mycotoxin detection and management strategy tailored to your needs. Thank you for your attention and interest, and have a great day.